Good afternoon, everyone.
Good afternoon, sir.
We are happy to see you, and we are glad to be here today again. It's been a while, so we are happy to see you. Today we want to take a very important topic in your SSCE. It is a very important topic, and such that even in 2025 NECO, the question came out, and we want to quickly take a particular topic of that. And that topic is cumulative frequency curve. Cumulative frequency curve, or Ogive. So today we say we are taking cumulative frequency curve, otherwise known as Ogive. Alright, that is what we are going to treat. Before we continue, let's quickly take our confession. Repeat after me, everyone. My memory is blessed by the Lord.
My memory is blessed by the Lord.
My understanding is enhanced by the Spirit of the Lord.
My understanding is enhanced by the Spirit of the Lord.
My assimilation is accelerated by the Holy Ghost.
My assimilation is accelerated by the Holy Ghost.
And I excel in my studies.
And I excel in my studies.
Amen.
Amen.
So let's quickly take one or two examples and solve. So we have gotten a particular question. Let's quickly see this example. The table below shows the frequency distribution of marks scored by 800 students in physics test. You have the mark in percentage, then you have frequency. 10 to 19, you have 35 students. 85 students scored 20 to 29. 150 students scored 30 to 39. 130 students scored 40 to 49. 105 students scored 50 to 59. Then 120 students scored 60 to 69. 30 students scored 70 to 79. 35 students scored 80 to 89. Then 60 students scored 90 to 99. Understand that if you want to plot the graph, you need to plot the upper class boundary against cumulative frequency. We are plotting upper class boundary against cumulative frequency. The cumulative frequency will be at the vertical side, then the upper class boundary will be at the will be at the horizontal side. Do we understand that?
Yes.
Okay, so let's quickly see. Of course, you know that before you plot your table, you first of all need to get your before you plot your graph, you need to get your table prepared. The first thing is you get your table prepared. So let's quickly see how to prepare the table for cumulative frequency. You have your mark in percentage. Then you have the frequency, which is F. So we list the cumulative frequency, you list the frequencies here. Alright, so 10 to 19, you have 35. You have 10 to 19 is 35, 20 to 29 is 85, 30 to 39 is 150, 40 to 49, 130, then 50 to 59, 50 to 59,
105,
105, then 60 to 69,
120,
120, then 70 to 79, 30, then 80 to 89,
35,
35, then 90 to 99, 60. Okay, so this is the information that we have from the questions. This is the information that we have from the question. Please, let's concentrate. I'm going to give you an assignment, and I will not play with it. All right. We are taking this information now. The next thing is for you to do is to get your class boundary. Don't forget I told us that For you to do your cumulative frequency, you need class boundary against cumulative frequency. You need class boundary against cumulative frequency. So the first thing you need to do is you have your class boundary. So for class boundaries, you can have both upper class boundary and lower class boundary. You can have both upper class boundary and lower. Will you concentrate? You can have both upper class boundary and lower class boundary. So the figures that are here, they are the lower class boundaries. Then the figures that are here are the upper class boundary. When you see this class mark, you will see that there are some numbers that are bigger, while some numbers are smaller, right?
Yes.
Of course, you can see 10 is smaller, 19 is bigger, 20 is bigger, 29 is smaller, then 30, then that's like that, and like that. Okay, now how do you do your class boundary from your class mark?
Yes.
Deduct 0.5 from the lower class, you will have lower class boundary. Add 0.5 to the bigger number, you have upper class boundary. So deduct 0.5 from 20, you have 19.5. Add 0.5 to 29, you have 29.5. So the next one will be 29.5, and that will be 39.5. The next one will be 39.5. 49.5, 49.5 to 59.5, 59.5 to 69.5, 69.5 to 79.5, 79.5 to 89.5, 89.5 to 99.5. Is that clear?
Yes.
So that is how to get the class boundary. And having done that, the next thing is for us to do the cumulative frequency. Cumulative frequency. And how do you do the cumulative frequency? Cumulative frequency means the continuous addition of all the frequencies. Continuous addition of all the frequencies. Okay, so that is the first one here. You know there is nothing on top. There is no frequency before this one, right?
Yes.
So you start with it. That's 35. Then you add the frequency here, which is 35, to this frequency. So 35 plus 85.
120.
120. Then 120 plus 150. 270. 270 plus 130. 400. 400 plus 105. 505. 170 is not 120. It's 170. 60 to 69 is 170. So let's quickly add again and see. 30 plus 85. 120, right?
Yes.
120 plus 150. 270. 270 plus 30.
400.
400. 400 plus 105. 505 plus 170.
675.
675.
Yes.
675 plus 30. 705. 705 plus 35.
745.
Then 740 plus 60.
800.
So this is the cumulative frequency. This is the cumulative frequency. Now, having gotten the cumulative frequency, the next thing is to go to our graph and plot our cumulative frequency. Now, we are plotting. We said on the vertical axis, we are plotting cumulative frequency. And on the horizontal axis, we are plotting what? Class boundary. At the upper class boundary, we are using upper.
Okay, that's how we are going to draw this one.
Yes. Okay. So you see the upper class boundary, you start from here and you label it like this. But that here, you like this, you label it like this. So, class boundary, upper class boundary as this, there is no need for range. You just make sure that you follow, the same centimeter. Is that clear?
Yes, sir.
Make sure that you follow the same centimeter. So the next, if the first line is what? The first line is we are using how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is, if you know in your thick lines, you just use one thick lines, one thick lines, or you leave one, you use one, you leave one, you use one, you leave one, you use one. You understand? Yes. If that is the pattern you are following, if that is the centimeter you are using, use the same centimeter for everything. Then if it is you want to use one, leave one, you use it like that. So you start from 19.5, first line, this is the first thick line, second thick line, third thick line, fourth thick line. So you have 19.5. In the next thick line you have what? 29.5. In the next thick line you have what? 39.5. In the next thick line you have what?
49.5.
49.5. Then the next thick line you have 59.5. 69.5.
79.5.
89.5. 89.5. 99.5. So that's it. Now, you now look at this one. Now, here you can use a normal scale. For your cumulative frequency, you can determine a suitable scale. For your cumulative frequency, you can use a normal scale. You can choose to use 100 so that it can contain it. You can use 100, 200, 300, 400, 500, 600, 700, 800, like that. You know, it's up to 800. You understand?
Yes.
Okay, or you can try 50. You know, if it is 50, that will be 16 lines. If 50 will not contain it, you can use 100. Are we getting it now?
Yes.
I will do another video to show us how to plot the graph using a normal graph chart. Please, let's try and understand from here. You can equally get it from. I think you get what I'm trying to explain now.
Yes.
On the x-axis, you can use one line, one thick line, one thick line. Or you use one, or you leave one, use one, leave one, use one. You understand? So on a standard graph, when you use one, you leave one, you are using 4 centimeter. On a graph that is not standard, if you use one, leave one, you are using 2 centimeter. I think you understand that.
Yes.
All right. So now let's use 100. 100 unit for 2 centimeter on the cumulative frequency axis. Okay, so you know you have 100, 200, 300, 400, 500, 600, 700, 800. So that is how it should look like. So let's quickly begin to plot. You have 19 to 35. Of course, you know this 100. Middle, that will be 50. Like half of it, that will be 35. You just trace it. You trace it, you trace it, you have it here. You start it. Then 29 to 120. This 100, this is 150, 120 should be here. You trace it under 29, you start it. Is that clear, everyone?
Yes.
Then the next one, 39, is to 270. 39 is to 270. This is 200. This is 250. 270 should be around here. So you trace it, you just feel like that. Then 49, 49.5 to 400. This is 400. You trace it to 49.5. Then you start it. 59.5. 59.5 to what? 59.5
505.
505. 505 should be slightly above 500. Then this 59, you trace it down. You see it, you trace it down like this, like this. This is where the two join, and you see this. Then 69.5 is to 675. This is 650. This is 75. Yeah. So you trace it. You trace it. Trace it. You trace it like this. And to 69. This is it. Then after that you have what? You have 79.5 to 705. This is 705, slightly above 700. Then you bring it up to what? 79.5. Start it. Then after that, the next thing is 89.5 to 740. This is 740 will be up here. Then you trace it, you trace it to 89.5. Then you start the last one is 99.5 to 800. 800, you trace it up to 99.5. And you start. After that, you just your curve is not always a straight line curve. It used to write S at the end. So at the end of drawing your curve, this is what you expect. You can see that it looks like it, like this. So this is how your curve will look like this. You can see it now that it looks like S. So this is a cumulative frequency curve. This is cumulative frequency curve. It will always write S like this. This is how it looks like. You see now. So why it looks like this is because you don't have an accurate scale. That is why this place is like this. It's supposed to be like this. Because our scale is not accurate like this. So that's why we have it like this. But we are going to come again with another example of this. But hopefully we are going to get a better chart graph, a better mathematics graph with charts. Then with that, I think we will trash out all our graph, all our graphical, all our mathematics questions that have to do with graph. And we are going to start with cumulative frequency. I think let's quickly solve the questions that follow. Say use the graph. The first thing is that construct a frequency cumulative table. This is a frequency cumulative table. Look at the question. Look at the question. Construct a cumulative frequency table. So this is a cumulative frequency table. Then the next thing is draw your Ogive. This is the Ogive. Then the next question now is find the interquartile range. Now we have to find one interquartile range. Interquartile range. Interquartile range is given by Q3 minus Q1. Q3 minus Q1. What do we mean by Q3? It means third quarter minus the first quarter. Are we getting it now?
Yes.
So, and what do we mean by quarter? Of course, you know the quarter of anything is 1/4. Abi?
Yes.
Okay. So when we say interquartile, we are talking about Q1 now will be 1/4 of 800. That's the whole that's the number of students that we have their data. Are we getting that?
Yes.
So that's going to give us our Q1 now will be 1/4 times 800. So 1/4 times 800, that will give us what? That will give us 200, right?
Yes.
So you now come to your, okay, that's Q1. This Q1 is called first quarter. Are we getting it now?
Yes.
This Q1 is first quarter. Then Q3 now is the third quarter. Q3 is the third quarter. That's 3 over 4 times what? Times 800. And that will give us what? This divided by this, that's 200. 3 times 200, that's 600. So that is, this is first quarter, this is third quarter. So interquartile said if you subtract the third quarter from, you subtract the first quarter from the third quarter, that is Q3 minus Q1. And that will give us 600 minus 200. Is are we getting it?
Yes.
Okay. Now, Q3 now, interquartile range now. Interquartile range is what? 400. So you now come here, look at the 400, look at where you have your 400. Look at where you have 400, then you trace it to the curve, trace it to the curve, then trace it down, trace it down. So, interquartile range now will be, so your interquartile range will be in the what? What do we get?
49.5.
49.5. Is that clear?
Yes.
Okay. Then the next thing that we are going to do is how we define the 70th percentile. When we say percentile, we are talking of 1 over 100. Are we getting it?
Yes.
When we say percentile, we are talking of over 100. So when we say 70 percentiles, 70 percentile is equal to 70 by 100 times 800. Are we getting it?
Yes.
So 20 cancel this, then you have 7 times 8, 56, okay? That's 560. So you come here, trace your 560, this is 550.
Yes, 560.
550 up here, then you trace to the curve, then you
Trace down. 59.
that's around 56, 60. Here is 59.5 and these are the middle again. So that's 60. 70 percentile is 60. Then, of course, you know, then the last one, which is the median. Which is the median? Median is what? Median. As we all know, median is the middle number, right?
Yes.
Median is the middle number. And that is 1 over 2 times the number of observation, which is 800. And that will be 400. So you come here, look for 400, you trace it. So median now is equal to interquartile, which is equal to what? Which is equal to what? 40, which is equal to 49.5. So those are the solutions to the questions that we have. We are happy to see you. We want to appreciate every one of you for waiting. Thank you for your time. And to our online followers, we want to appreciate you for coming online to study. It is our prayer that the Lord of heaven will grant you wisdom, knowledge, and understanding, and it will help you to understand all that you have learned. Don't stop learning, don't stop growing. Because the day you stop learning, that day you start to die. Thank you very much.